All right, let's take a look at some of that Extrema stuff that we were just talking about. We're going to look at the candidates test to find absolute extrema. Well, the number one rule of the stock market trading is buy low and sell high. If we knew when those high points and those low points occurred, we'd be well on our way to making a fortune. Today we're going to expand our learning on the stock market with some more function analysis. The value of a stock T days into February is given by that function for 0 to 28 for the days of February. Find the critical points of S of t. So remember, the critical points are simply where the derivative is either 0 or undefined. So go ahead and find the first derivative of that function. This is a straightforward polynomial, so there's our first derivative. I'm going to apologize now for what's there and what is likely to come in the future. I see that there are two different variables being used. I'm very likely to switch back to x's just because that's more familiar. So just bear with me. Everything should always be the same variable. I'm going to probably switch accidentally. So we've got our polynomial, but now we need to find where it equals 0. It's a polynomial, so it's not going to be undefined. So now we're going to go ahead and factor that. If you want to go ahead and pause this and factor that, go ahead. It's always good practice to pause the video and practice your factoring, but that's what you should have gotten for your factors. And then when we set those equal to 0, we're going to get that t equals 5 halves and t equals 18. Now we want to know at which t values does the stock market have a relative maximum. Well, let's think about what a relative maximum would look like graphically. A relative maximum would be where there's a peak. So on this side of that peak, what's the slope? It's going to be positive, and on this side of the peak, the slope is going to be negative. So we're going to make what we call a candidates test. And we've done something similar to this back when we were looking at limits, but we're going to make a bar, number line, and on that number line we're going to put our candidates, our critical values. And then we're going to determine on each side of those critical values, remember those critical values are where the first derivative is equal to 0, so there's a horizontal tangent. So let's pick a value, a nice easy value to plug in that's less than 5 halves. If we plug in 0, we're going to get a negative times a negative, which is a positive. Let's plug in a number between 5 halves and 18, so let's plug in 10. We're going to get a positive and a negative, so we're going to have a negative. And something bigger than 18, 20, we're going to get a positive and a positive, so it's going to be positive. So if you think about this, the slope is going up, the slope is going down, and the slope is going up. So where is there going to be a relative maximum is right here at 5 halves because the slope changes from positive to negative. So go ahead and pause the video and find out what is the stock at that instant. Remember, to find the value of the stock at that instant, you are actually plugging that 5 halves back into the original function, not into the slope, into the first derivative, but into the original function. So we get $251.46. At which values does the stock have a relative minimum? Well, we can look at that same number line, or that same little graph. It's going from a negative slope to a positive slope, so it's going to have a minimum at t equals 18. Again, because the slope changes, the derivative changes from negative to positive. And then go ahead and pause the video again and find the value of S of 18. What is the value of the stock on the 18th day? Now we want to find out, question number 4 and 5, what is the absolute highest value attained by the stock during the month of February? And what is the absolute lowest value attained by the stock during the month of February? Well, we know that the maximums are going to occur at the peaks and the minimums are going to occur at the valleys. So we know what the critical values are. Let's evaluate those critical values. Any maxes and mins are going to occur either on the first day of the month or at the peaks and valleys. So on day 2.5, 5 halves, possibly on day 18, or possibly on the last day of the month. So if we take those values and plug them into our original function, we're going to get 230. You can pause the video and get these values if you want, but I just put them in the calculator, 251.46. We already calculated this one together as well, those two middle ones. And on the 28th day, it's 446.53. So if we look at those values, what is the absolute maximum of the stock during the month of February? Well, the absolute max is that 446.53, and it occurred on day 28 when T is 28. By our candidates test, we can also see that our absolute minimum is that $3.20, which was also a relative minimum that occurred on day 18. Seems like the candidates test is pretty straightforward. To find the absolute, sometimes they'll be referred to as the global maximum or minimum. To find those, the first thing you need to do is find and list all the critical values and the endpoints. Remember that your critical values are where your first derivative is either equal to 0 or is undefined. The next thing you're going to do is compare the values that those critical values give you from the function. The easiest way to do this is generally to make a table. Then lastly, after you compare those f of x values, the largest one is going to be your absolute maximum. The smallest one is your absolute minimum. Example number 1. At which x values does that function have an absolute maximum on the closed interval? So go ahead and pause the video and do those 3 steps that we just listed above. I found my first derivative. I set my first derivative equal to 0 and found my critical values. So I have critical values of 0 and 2. So now I need to make my table. So in my table, I'm going to put my endpoints, -2 and 4, and I need to put my critical values, 0 and 2. And then I'm going to evaluate those in my original function. If you want, go ahead and pause the video to do that. When you do that, you should get -8, 12, 8, and 29. It's asking for the absolute maximum. The absolute largest value is right here of 29. It occurs when x equals 4. Number 2, the graph of f prime of x is shown below from -7 to 7. Remember, this is the graph of f prime of x. It has horizontal tangents at x equals -3, x equals 2, and x equals 5. And a vertical tangent at x equals 3. List the candidates for the absolute maximum of f prime of x, and let's justify our answer. So the important thing to remember in this problem is this is the graph of the derivative, which means this is the graph of the slopes. So if you look at 5, 5 is where the derivative is equal to 0. That means that the original function has a maximum or a minimum. Well, on the on the left side of 5, my slope is positive, which means the original function goes up. On the left side of 5, the function is negative, which means the graph goes down. So the candidates for the absolute maximum, first of all, I need to list the endpoints. Let's make sure we don't forget that. The endpoints of this graph are going to be at x equals -7 and x equals 7. And then the relative maximums are going to occur when at x equals 5. And is there another place where the graph goes from the positive to the negative? There's not. So that would be the candidates for the absolute maximum. Similarly, the candidates for the absolute minimum, again, we need to list the endpoints, -7 and +7. And then, whoops, I forgot to put relative max. And this one we need the relative mins, which means that the graph needs to go from, if you think about this, the slope is negative below, so it's going to go negative, and then it goes positive, so we're going to have a relative minimum at x equals 1. -1, sorry. Number 3, the position of a particle is given by that function, e to the -t times the sine of t, for the interval between 0 and 2 pi. Find the time at which the particle is the furthest to the left and justify your answer. So one thing we need to remember is that furthest to the left means that we're finding an absolute minimum. Remember, we've talked about this in previous classes, previous videos, that the first derivative, the velocity derivative, if it's positive, it's moving right or up. If it's negative, it's moving left or down. So if it's moving down, it would reach a relative minimum or an absolute minimum. We need to find where the first derivative is equal to 0. So let's find the first derivative. Go ahead and pause the video to do that. And reminder that you're going to have to use the product rule as well as within that product rule the chain rule. So we did our 1 prime 2, so the derivative of sine is cosine. So 1 prime 2 plus 2, so the sign we kept the same. The derivative of e to the negative t is e to the negative t, but the derivative of the negative t is that negative 1, which makes that negative. We're then, to make this a lot easier, going to factor out that e to the negative t, because if you'll remember, e to the negative t is simply a constant. So when we set this equal to 0, we would just divide by that e to the negative t. It's just a constant. What we actually need to find then is when is the cosine of t minus the sine of t equal to 0. That simply is when is the cosine of t equal to the sine of t. Remember, that's going to happen in the first quadrant when the sine and cosine are both positive, or in the third quadrant when the sine and cosine are both negative. So now we need to make our t-chart and make our candidates test to find where our absolute minimum is. We include our endpoints, we include our candidates and our candidates test, or we include our critical values. When we plug this into our original function, we're going to get 0, roughly 0.322, roughly negative 0.014, and then we get 0 again. So our minimum, this is our smallest value. Our minimum is going to occur when t equals 0. T equals 5 pi over 4. Let me know if you have any questions when we come to class.